Hello, and welcome to Math with Mr. Bill. I'm Bill Anderson. Today we are working through a series of questions from a midterm to help one of my students review for an upcoming final. And this comes from the second midterm. This is problem number 2. We're given a differential equation. We're given y prime is equal to 3x times the natural log of xy, and we're asked, is this separable? Now, to separate an equation means to carry all of the y values to one side and all of the x values to the other side. And we'll kind of see what we've got here. So we've got y prime, which I can write out as dy dx, which will be useful for us to determine whether or not this is separable. And then we've got 3x and then the natural log of xy. As it stands right now, the natural log of xy, those are kind of embedded together, and there's no real way to separate that using division or anything like that. But because it's inside a natural log, the product there, x times y, becomes a sum. And so I can rewrite this natural log as the sum of the natural log of x plus the natural log of y. So now the question is can I get all of the x's by themselves and all of the y's by themselves? And that's going to be difficult, and it's going to be impossible, actually. If we look at the dx, we usually move that over by multiplying both sides by dx. And in order to get all of the y's onto the other side, we really need to be able to divide it. And if I distribute that 3x, you'll see we end up with this mixed term, and there's really no way that I can divide out the y portion of this problem into something that will work, into something that will make it into a separable differential equation. If I move the dx over, there's really no way to divide by natural log of y without introducing it to the first term. And so this equation, this differential equation, is not separable. We'll have to use a different method to solve it. The second part of this question asks us, well, if it's not, whether or not it's separable or not, is a function a solution to that differential equation? So we're given y is equal to e to the 3x. And we're asked, is this a solution to that equation? And really what we need to do is see if it satisfies the equation. So if we look at our original differential equation, we've got y prime equals 3x times the natural log of xy. Okay, so we've got a y and we've got a y prime. Well, I know what y is. It's e to the 3x. But what about the y prime? Well, y prime is just the derivative of y. And so y prime from my supposed solution is 3e to the 3x. So now what I'm asking is, somehow, is 3e to the 3x equal to 3x natural log of xy? Is that a true statement? Well, let's plug in the y, and let's see if there's anything that we can do to this. So we've got 3x times the natural log of x times 3e to the 3x. Okay, so in order for this to work, the things have to cancel. Things have to kind of go away. And I don't know if that's going to happen. So let's see if we can make that work here. So we've got a product in the natural log. That may help. Let's see what happens when we break that up. We get 3x times the natural log of x plus the natural log of 3e to the 3x. That's not looking good. If we had a division, we'd get a subtraction. Maybe we'd get something to cancel. But I don't see that as happening. If I break up the second logarithm in its product, I get 3x times the natural log of x plus the natural log of 3 plus the natural log of e to the 3x. And here we get something a little more substantial. The natural log of e to the 3x just becomes 3x. And so this becomes 3x times the natural log of x plus the natural log of 3 plus 3x. And I think at this point you can tell that these don't work. And you can even just show that a point wouldn't work. So if I say if x is equal to 0, let's just say if x equals 0, then 3 times e to the 3 times 0 is equal to 3, but 3 times 0 times the natural log, it really wouldn't matter at this point because I'm multiplying by 0. That's equal to 0. So we get different outputs for just one input, and already we know that those two aren't the same. So the original problem's not separable because there's no way to bring all of the y's to one side and all of the x's to another. And the given solution is not a solution to the differential equation. And that's it. So I appreciate you watching, and I'll see you in the next video.